Good morning, my dear children. Today our learning objectives to learn about collision theory and one more question, Arrhenius equation. These are the two questions you have to discuss now. We are learning the chemical kinetics, unit number 7. I think that we completed about that, the rate of the chemical reaction, and about the stoichiometric and rate of a reaction, average and instantaneous rate. These are all already we discussed that one. And about the rate law, rate constant for isomerism. Rate constant for an isomerization. The differences between rate and rate constant of a reaction. The rate equation, that's one of the derivation, the integrated rate law for a first order reaction, pseudo first order reaction, integrated rate law for the zero order reaction, and examples, some of the examples including half-life period of a reaction, and about that calculate the rate, the half-life period for the zero order reaction. Everything we discuss, and about that some of the examples. What are the examples? And we can be discussed. There is a later. Now we can be discuss about the collision theory and about the Arrhenius equation. Here, what is the, before that we have to learn about what is the uses of this collision theory means. To predict the rate of chemical reaction for a gaseous molecule. Here the collision theory is used to predict, it can be measured, it can be calculated, the rate of the chemical reaction for a gaseous molecule. Here what is the main idea about the collision theory means? It states that a chemical reaction's rate is proportional to the number of collision between the reaction molecule. They are having a number of collision. They are colliding, hitting. Here, the collision theory means we have to learn about the three types of collision theory. Perfect elastic collision, inelastic collision, and perfectly inelastic collision. Okay, these are all some idea. Before that, the collision theory was proposed independently by Max Strauss in 1916 and one more, William Lewis in 1980. Here what is about this theory? What is the main concept of this theory? This theory is only based on the kinetic theory of the gas. Kinetic theory. So according to this theory, the chemical reaction occurs as a result of collision between the reacting molecules. They have some collision. Suppose I am taking two reactant X and Y. Suppose I am taking how they are collide with one another. Here one of the very good example. What is the example means? Let us consider one of the equation. I am taking one of the equation, gaseous molecule equation. Reacting, two reactant I am taking, that is a A2 gas, this is a gaseous state, plus B2 gas gives, we get the product, that is a AB gas. So we have to balance the equation, that is 2AB, okay. Here, the rate of this reaction would be proportional to the number of collision per second between the reacting molecules. Which are the reacting molecules? A2 and B2. Here we can learn about the rate. The rate of this reaction would be proportional, directly proportional. We can say proportional to the number of collisions per second between the reacting molecules. So I am writing one of the formula. Rate is directly proportional, that is number of molecules colliding per liter per second. This is one of the collision rate. Okay, this is the collision rate. So we can be right. The number of collision is directly proportional. The number of collision is directly proportional to the concentration of both A2 and B2 molecules. So I am writing on short form. Collision rate is directly proportional to concentration of reactant A2 and the concentration of reactant B2. Now I am using one constant, okay, one of the constant, that is Z. So I am writing the equation. Collision rate is equal to constant Z, the concentration of reactant A2, concentration of reactant B2, where Ez is the constant. Okay. Next, the collision rate in gases can be calculated from kinetic theory of gases. Already I told you that. One of the important point. This theory is based on the kinetic theory of the gases. I am right. Here, the collision rate in gases can be calculated from kinetic theory of gases. For a gas at room temperature, that is 298 Kelvin, and 1 atmospheric pressure, each molecule, one of the very important point, each molecule undergoes approximately 10 raised to 9 collision per second. What is the condition? At the room temperature, this is only for gaseous, okay? For a room temperature, that is 298 Kelvin, and 1 atmospheric pressure, each molecule undergoes approximately how much collision per second? 10 raised to 9 per second. Collision per second. That means that is 1 collision is 10 raised to minus 9 second. If every collision result in reaction, the reaction would be complete in 10 raised to minus 9 second. In actual practice, this does not happen. Because what is the reason means, all collision are not effective to lead to the reaction. All collision is not effective. Some collision may be effective, some collision may be not effective. It is based on the proper alignment. The collision may be, it is based on the proper alignment. There have 2 alignment. We can be explained later. Proper alignment. What is about the proper alignment? What is about the improper alignment? If your alignment, that is the collision is based on such like thing. Anyhow, here, all collision is not effective. Some collision is may be effective. Some collision. Here, all collision is not effective to leads to the reaction. Anyhow, in order to react, the colliding molecule must possess a minimum energy. Each and, that means you can be say all molecules, all colliding molecules, which are the molecules are colliding, get ready for colliding. That colliding molecule must possess a minimum energy. That is called as an activation energy. Okay? So don't forget about the activation energy. The colliding molecule must possess a minimum energy called activation energy. The molecules that collide with less energy than activation energy will remain intact and no reaction occur. Now I am taking some fraction of effective collision. Fraction of effective collision, that is, we can be written as F. Okay, that is a small f. We can be used small f. Small f is equal to e power minus Ea by RT. F is equal to e power minus Ea by RT. Okay. Next, one more small problem about that. Let us we can be calculate the collision factor. One of the collision factor F. Okay. This for a reaction having the activation energy, that is Ea. Ea means activation energy of 100 joule mole inverse. That is, activation energy is 100 kilojoules. 100 kilojoules mole inverse at 300 Kelvin. We know the formula F is equal to e power minus Ea by RT. All of you know the value here, Ea, that is activation energy. I given that activation energy is equal to 100 kilojoules mole raised minus 1. So I am writing here F is equal to E. F is equal to E. The power I am writing, activation energy, that is 100 into kilojoules. So I am writing 100 into 10 raised to 3 joules mole inverse divided by, what is the value of R? R is one of the constant value. Am I right? Constant value. That is 8.314. 8.314 joules Kelvin raised to minus 1 mole inverse. 8.314 J A raised to minus 1 mole inverse into, and also I give the temperature is about the 300 Kelvin. That I am going to write 300 into 300 Kelvin. Just I am writing and substituting, we get F is equal to e the power 40. That is approximately 4 into 10 raised to minus 18. 4 into 10 raised to minus 18. Here, out of this 10 raised to 18 collision, only 4 collision are sufficiently energetic. Out of this 10 raised to 18 collision, only 4 collision are sufficiently energetic. That is, the reactant is converted to product. That is, conversion of reactant to product. This fraction of collision is further reduced due to the orientation factor. We can discuss about the diagram. What is about the diagram? How can you draw the diagram? There is a proper alignment and improper alignment. Now we can discuss which are the effective collision and which are the ineffective collision. Suppose I am taking the reactant. Okay, reactant, that is A, above A, below another one A, another reactant. Okay, above and below. Okay, that is a reactant A, and alignment another one reactant, that is plus B, that is above and below B. So these are the reactant, that is A plus B, the reactant. This type of an arrangement we can be saying proper alignment. Which alignment? The proper alignment. Okay. Suppose undergoes collision. Suppose the A on collide with the B. Collision. A on hit with B or B on hit with the A. It is an effective collision because both they are colliding. Okay. Effective collision. So it split up into the product. Which are the product means one of the A combines with other B to form AB products. A and B. Okay, AB products. And another A also combines with the B, that is collide with the B we get another one product. That is, it is split up, it is divided into two products. One is AB and another one is also AB. Can you understand? This type of an collision, this type of a collision, we can be say the proper alignment. This is one of the proper alignment. We get the correct, that is a correct product. That is A on combines with the B, we get AB. That is, all of you know, am I right? A on combines with the B means we get AB. This type of an alignment we are saying the proper alignment. That is a reactant. From the reactant undergoes the effective collision, we get the correct product. Suppose what happened, the improper alignment. Here I am arrange the reactant like the linear arrangement, one of the linear like that. That is A and another one A. Okay, this is type of one of the linear arrangement, A and A, plus another reactant B and B. Suppose what happened, these two molecules undergoes collide. We get one of the collision, of course, but this collision is not a correct form of the collision. This type of the collision we are saying ineffective collision, not effective collision. It is an ineffective collision. Because what is the reason here means A on collide with another one A and B on collide with another one B. Okay, sometimes it may be, collision may be occur, but it is not a correct way. It is not an effective collision. Because A is touched with another one A and B is touched with another one B. But one AB undergoes colliding, but that is not a correct form. Okay. But next what happened? What is about the product? Here, the A collide with the A, we get AA. And B on collide with the B, we get BB. So just we look the reactant, previous reactant. Here A on collide with A, so we get AA. Am I right? B on collide with the B, we get BB. So the same reactant only we get the product. Its product is not come. Am I right? It may be product, but just we are comparing the reactant. We get that AABB like that. The previous, that's a proper alignment. Proper alignment, we get the correct product is ABAB. This is a proper alignment. But now we get, it is not a proper alignment, improper alignment, because it is an ineffective collision. So we get not a product, we get a reactant. Okay. Now, as per this diagram, that is the orientation of the reactant. That is one of the schematic representation. Here, what is the diagram explained about the importance of proper alignment of the molecule which leads to the reaction. The fraction of effective collision, that's we can be written as F, have a proper orientation. It is given by the steric factor, that is P. Okay, steric factor means P. So we can write the equation. Rate is equal to steric factor, that is P, into a fraction of effective collision, that is F, into collision rate. Already we learned about the collision rate. What is the formula? Can you anybody remember? Collision rate is equal to Z into molecules A2 into, that is a concentration of A2 and a concentration of B2. Am I right? So just I am writing the collision rate. So what is the formula here? Rate is equal to P into F into collision rate. We know that what is the value of F? What is the value of F? We know that already we discussed that on the fraction of effective collision. F is given by the expression. What is the expression? F is equal to E the power EA by RT. What is the value of F? F is equal to E the power EA by RT. Am I right? What is the collision rate formula? Collision rate is equal to one of the constant Collision rate is equal to one of the constant. What is the constant? Z concentration of A2 into concentration of B2. Concentration of A2 into concentration of B2. Okay. So we can written as rate is equal to P into P means steric factor, P into F, value of F, we know that only. Value of F is equal to E power EA minus of EA divided by RT into Z, that is a collision rate, Z into concentration of A2, the concentration of A2, that is a reactant A2, into the concentration of reactant B2. That's the equation we can written as equation number 1. As per the rate law, we can be written as rate is equal to K into the concentration of A2, concentration of B2, concentration of A2, the concentration of B2. What is about the K? K is called as rate constant. K is called as rate constant. Okay, this is about the equation number 2. So, okay, the first one is equation 1 and second one is the equation 2. So, just we are going to compare the both equation. Equation number 1 and equation number 2. Just we are going to compare. So, we get the rate constant K, that is K is equal to P Z E, the power of minus EA by RT. Okay, what is the value of K? K is equal to P Z E, the power of EA by RT. Okay. Next, we can discuss about the Arrhenius equation. Arrhenius equation ARR HENIUS, Arrhenius equation. That is the effect of temperature on reaction rate. The effect of temperature on reaction rate. We know that the rate of the reaction increases with increasing temperature. The rate of the reaction increases with increase in temperature. If the temperature is increased, the rate also will be increased. Okay, here some of the reaction at room temperature. Suppose I am taking some few reaction at room temperature. The rate tends to double when the temperature is increased by 10 degrees Celsius. Okay. The rate tends to double when temperature is increased by 10 degrees Celsius. How can you explain means? Suppose I am taking 2 test tube. One test tube is I labeled as A and another one is labeled as B. These are the 2 test tube. One is A and another one is B. One test tube I am taking 5 ml of cold water, that is test tube A. The test tube B I am taking 5 ml of hot water, that is in test tube B. Both 2 test tube I am adding phenolphthalein indicator, phenolphthalein indicator. Okay, both the 2 test tube I am adding phenolphthalein indicator. Okay, all of you know that one, it is a pink color, am I right? Just we are adding, okay, phenolphthalein indicator. And then I am adding magnesium granules on the both 2 test tube. Okay, that is try to understand that on the concept. The first test tube A is a cold water, a drop of phenolphthalein indicator and magnesium granules. What is about the test tube B? 5 ml of hot water, a drop of phenolphthalein indicator and magnesium granules. Okay, this is an experiment. Now we are going to observe what is happening in the test tube A and B. Here the test tube, that is the solution in test tube B, change to pink color. Okay, the test tube B change to pink color. There is no color in the test tube A because test tube A having the cold water, test tube B have the hot water. That is, the hot water reacts with magnesium. So what is happening here? The hot water can be easily react with the magnesium. What is the symbol of magnesium? All of you know that one, Mg. So Mg reacts with the water molecule H2O. We get Mg cation, Mg2 plus cation. And also we get OH minus ion, and also we get H2 gas, the liberation of H2 gas. So how to balance the equation? We have to write 2 water molecules, then 2 OH, 2 water molecules, 2 OH minus ions. Okay, now here another some of the example. We know some of the reaction, that is a large number of reactions we know which do not take place at room temperature. Some of the reaction does not take place at the room temperature, but sometimes it occurs readily at a higher temperature. One of a very good example. What is an example mean? The reaction between hydrogen and oxygen. All of you know that one. Hydrogen combines with oxygen to form water molecules. Am I right? Here, hydrogen and oxygen to form water takes place only when an electric spark is passed. Okay, when an electric spark is passed. How can you write the equation? H2 plus half O2. Am I right? H2 plus half O2 gives H2O. Next, we can be discuss about one of the very important question, my dear children. Very, very important question. Arrhenius equation. Arrhenius equation. What is about the Arrhenius equation? It's one of the very important for the 2 mark and 3 mark question. Otherwise, definitely it is must in 5 mark question. Very, very important 5 mark question also. Suppose the question we are asking about the 2 mark question means you have to write the formula is enough. Okay. Suppose it is a 5 mark question means you have to write full. Arrhenius suggested that the rate of most reaction vary with the temperature in such a way that the rate constant is directly proportional to E, the power of minus of EA by RT. That is one of the expansion. And also Arrhenius proposed a relation between the rate constant and temperature. He proposed one of the relationship between rate constant and temperature. Anyhow, we have to write one formula. What is the formula? K is equal to AE power minus of EA by RT. Minus of EA by RT. Here, you have to say A. What is about the A? A is a frequency factor. A is a frequency factor. What is about the R? R is a gas constant. And what is about the T? T is a temperature. We can be say absolute temperature in Kelvin. Okay, absolute temperature in Kelvin. And what is about the EA? EA means activation energy. Activation energy of the reaction. It's a very, very important question for the 2 mark question. Now when we are going to write the expansion, how can we write the derivation? EA is the activation of the reaction. Here, Arrhenius considered as the minimum energy. Some of the minimum energy of a molecule must have possessed to react. Here, above this expression, I'm taking in this equation, that is K is equal to AE minus of EA by RT. Here I am going to take logarithm on both side of the equation. Logarithm. I'm taking one of the logarithm. Okay, anyhow, the first equation I am going to write 1. Okay, equation number 1. Now I am going to take the log both sides. That is log. That is ln k. Ln k is equal to ln ae, the power of minus of ea by rt. Minus of ea by rt. That is ln k is equal to ln a plus ln e, the power minus EA by RT. ln k is equal to ln A plus ln E minus of EA by RT. We know one formula, log E, log E power m. Log E power m is equal to m log E. Am I right? Log E power m is equal to m log E. As per this formula, we can be right. Log A, how will you write? Here ln E power of minus EA by RT, ln E, the power of EA by RT, how to write? ln A plus minus of EA by RT into ln E. As the above formula I am writing here. Here we know ln E is equal to 1. Here the ln E is equal to 1. So ln A minus EA by RT into 1. ln A minus EA by RT into 1. So we can be written as ln k is equal to ln A minus EA by RT. EA by RT. And now I am going to splitting the R and T. So I am going to write ln k is equal to ln A minus EA by R into 1 divided by T. That's equation number 2. This formula is based on y is equal to c plus mx. C plus mx. Here means this equation is in the form of the straight line y is equal to mx plus z. That is already we discussed that one. When we are plotting ln k versus 1 by t. ln k versus 1 by t, we get the straight line with a negative slope. Straight line with a negative slope minus EA by RT. So, second we can be discussed that one. If the rate constant for the reaction at two different temperature is known, one of the condition, if the rate constant, one of the rate constant for a reaction at a different temperature, I am taking the temperature is one may be a T1 and another one may be a T2. Suppose I am taking two different temperature. If the rate constant for the reaction at two different temperature is known, we can calculate the activation energy. How can you calculate the activation energy? Okay, if the rate constant for the reaction at two different temperature is known, if you have known means, we can be calculate the activation energy. That's the temperature means T is equal to T1 and the rate constant K is equal to K1. Okay, temperature T is equal to T1. The rate constant K is equal to K1. So I am writing the equation, that is the first equation, equation number 1, first equation. What is the first equation? First equation already we wrote that one. Now we can become here. ln K1 is equal to ln A minus EA by RT1. Okay. Now I am taking for the equation number 2. Okay, not the first equation, from the equation number 2. Ln K1, because the rate constant is K1, am I right? K is equal to K1. And ln A minus EA by R T. I am going to the temperature T1, RT1. That is equation number 3. Next, at temperature T is equal to T2, the rate constant K is equal to K2. The rate constant K is equal to K2. Okay. So, I am writing the next one equation for the K2. Ln K2 is equal to ln A minus EA by RT2. EA by RT2. That's the equation number 4. Am I right? That's the first equation over, second equation over, third equation over, and the fourth equation over. Now I am going to fourth equation minus third equation. 4 minus third equation. I am going to write ln K2 minus ln K1 is equal to ln A minus EA by RT2 minus ln A. Okay, RT2 minus, I make it on bracket here, okay? Okay, otherwise little more confusion. Okay, I make it on bracket ln A minus EA by RT1. EA by RT1. Okay. Second, I have one more step I am going to write. Ln K2 minus ln K1 is equal to ln A minus EA by RT2. Here minus, okay, minus ln A plus, because the plus means here minus into minus, that, okay, minus into minus plus EA by RT1. EA by RT1. So I am going to cancel here. Which are the possible of cancelling here? Ln A, that is plus ln A, and minus ln A I am going to cancel here. Okay, that is we can write ln A. Okay, then I am going to write the remaining. Ln K2 minus ln K1 is equal to minus of EA divided by RT2 plus EA divided by RT1. EA divided by RT1. Next, we have to write the plus term first. Okay, the plus term. Okay. So I am going to write here ln K2 by K1. Ln K2 by K1 is equal to EA divided by R. EA divided by R. It's a common factor. Okay, EA divided by R into, I am going to write bracket 1 divided by T1. Okay, because the plus term I am going to write first. 1 divided by T1 minus 1 divided by T2. Okay, in bracket 1 divided by T1 minus 1 divided by T2. Now I am converting the log ln. That is actually log, not log, ln. Okay, ln I am going to convert into log, log. Okay, so I am giving one value. What is that value? So ln is converted into log, means we must give one value. What's the value? 2.303. Already we discussed that one. Okay, 2.303. That is ln is converted to log, means we have to give the value 2.303 log log K2 by K1. K2 by K1 is equal to EA divided by R. I am going to cross multiplication, the above equation, cross multiplication, that is 1 into T2, 1 into T2, that is T2 minus 1 into T1, that is T1. T2 minus T1 divided by T1 T2. Okay, T2 minus T1 divided by T1 T2. So log K2 by K1 is equal to EA divided by 2.303 R T2 minus T1 divided by T1 T2. Okay. Next. Here already we wrote the equation, that is above equation ln K2 minus ln K1 is equal to minus of EA by RT2 plus EA by RT1. Already we wrote this equation. But anyhow, this equation is about two equations. This equation can be used to calculate EA from rate constant K1 and K2 at the temperature T1 and T2. Okay, this equation can be used to calculate EA from rate constant K1 and K2 at temperature T1 and T2. Okay, so my dear children, please learn this question. Anyhow, today assignment, this derivation I am going to give this equation, very very important question. So please learn and write this question. Arrhenius equation for the 5 mark question. Write assignment, today assignment, write Arrhenius, Arrhenius, Arrhenius equation. It's a page number 220 and 221. Thank you all of you. Thank you. Have a nice day.